Hey everybody, this is Mr. McKee with CIS 115. Today I'm going to be going over Lab 3.2.2.3, which is setting up a PLApp with a Raspberry Pi. Alright, so on the left screen I have my instructions, and on the right screen I have my live document viewer showing my components. Now today we're going to be using the Raspberry Pi power supply for a Model Pi 4 Model B. I've got a 1 gig Model B. Have an Arduino, but we're not going to be using that today. That's just referenced in the picture, like right here. That's our Arduino, and then we have our USB cable that's going to hook between our Raspberry Pi and our Arduino. I'm going to put those to the side. We also have our micro SD card, which in this case, this is a 16 gigabyte card, not formatted, or yeah, it's formatted, but the software is not loaded on it yet. And then an adapter. All right, this is an adapter for a USB adapter for my micro SD card. All right, so I'm gonna go ahead and show you guys this power supply. This is a USB-C, all right, power supply, and this is rated for a Raspberry Pi Model 4, so it has 3 amps, 5.1 volts. All right, so that's it right there. All right, like maybe 4 foot long, I think. I'm actually going to plug that in. I've got a power supply on my switch rack, so that'll just be there when we need it. We don't need it yet. All right, take out my Pi. Now when you take out these Pis though, make sure, try to keep your hands off the board as much as possible. So I'm just going to grab right there. All right, just to reference you guys to the board. All right, and actually pretty much like that, but there's your Ethernet adapter, USB 3.0s, USB 2.0s. You got a headphone jack, 2 I guess those are micro HDMI for a dual monitor. You have a camera plug and display port, and then your power supply right there for USB-C. All right, GPIO pins. If you want to hook up a PoE hat, you'd plug it up right there. And there, all this is labeled on the board, but I know you can't really see it. Kind of sort of see it. All right, but for now, we're just put that on there. Now, micro SD card. One side doesn't have any pins. The other side has the shiny pins. All right, those pins are going to go into the back of this. I guess if you consider this the back of this USB adapter, it's going to plug in with this on top. It's going to plug with the pins facing down. All right, and it just plugs right in there. All right, and I'll let that sit for now, and I'm going to read through these instructions. All right, and okay, this is the Raspberry Pi. You can put Jupyter Network software on there. It's going to connect to the internet via Wi-Fi or Ethernet. Mine's going to be wired Ethernet. All right, and then from there, this is referencing your GPIO pins. All right, to digitally to a physical world, and then also you have your Arduino board that can either be analog or digital, and that's going to connect to the Raspberry Pi with a USB cable. Now, on my previous lab videos, I did use a Adafruit Metro board. So that's it right there. We can use that, but what I'm going to do, I'm just going to leave that from the previous lab. We had the LED plugged up already, and with the 330 ohm resistor. That's going to be I'm just going to leave that the way it is. If you notice this is a little bit different, which I didn't notice a lot of the differences when I ordered this, but if you notice this has a USB-B power supply. This has a USB, is that an A power supply? That's like your power supply coming from a printer, or the actual plug coming from a printer going to a computer, like the old school adapter. So I have a couple of those, which are these adapters, and then you'd need for this Metro, you would need a USB to USB-B adapter to power that. So if you're going from here into the Raspberry Pi, you need that type of adapter, and then this one going from here into your USB on a Raspberry Pi. So a little bit different, but those are both Arduino compatible boards. But just to show you guys that, but I'm going to set that to the side too, since we're not using it. All right, so Cisco Prototyping Lab is a set of hardware and software components that enable students and instructors to learn about and to prototype and model various IoT, digitalization, and data analytics solutions. All right, the hardware components are part of the Prototyping Lab Kit, PL-Kit. The PL Kit is based on open hardware prototyping boards such as the Raspberry Pi and Arduino, and includes additional sensors, actuators, and electronic components. The PL Kit can be used to build sophisticated prototypes of end-to-end IoT systems that can sense and actuate the real physical world, analyze and process the data at the fog layer, and connect to networks and cloud systems. The primary software component of the Prototyping Lab is the Prototyping Lab app. All right, I'm going to show you guys how to install that. The PLApp is a software platform running on a Raspberry Pi that exposes a web interface based on a concept of notebooks. A notebook is an interactive web page where content is distributed in what are called cells. The first cell type is called Markdown, and is a cell that contains standard objects such as text, images, videos, etc. The second cell type is called Code cell, and is a cell with executable code of different programming languages. The default is Python. All right. A notebook can be used as a lab where the explanatory text is placed with executable code, and together can create a scaffolded learning experience. The explanatory, I don't know why it's hard to say that, text guides the student through the learning experience, while hands-on labs are acquired by modifying, examining, and executing executable code. All right. A notebook is also a great tool that can be used to prototype IoT systems, interconnect with existing cloud services using APIs, etc. In a notebook, application code can be split between multiple code cells, executing only part of the code that is just being developed or troubleshot. Moreover, using markdown cells, documentation, and explanatory text can be added between cell codes to provide a clean, easy to understand, rapid prototyping interface. Okay, that was a whole bunch of stuff. All right, the PL app together with the PL kit are enablers for IoT, digitalization, and data analytics learning and rapid prototyping inside of a classroom. PL app provides a web-based environment to access the software and hardware resources of the Raspberry Pi, leveraging the concept of Jupyter notebooks. All right, so Jupyter Notebook, I'll show you guys that, but it has code, lab books, dev environment, and that works with the PL app. So the PL app, if you guys have used a Raspberry Pi but just logged into it directly into the desktop, this is a little bit different, but just understand this is kind of like set up for people that are new to Raspberry Pis, and it gives you it puts a web server on top of the Raspberry Pi that you can access a lot of this information for these labs through. All right. So with PLApp, you can access existing IoT fundamentals labs in the course materials folder, or write your own new applications directly on the board, execute them, and monitor the output of the board with various visualizations. Once this setup is done, the Raspberry Pi and the Arduino connected to the Raspberry Pi can be controlled from the PLApp web interface. And since this lab, I know you're supposed to have in this diagram, the Arduino is plugged into the Raspberry Pi. I'm not doing that for this lab, just so you know that. All right, this lab provides a basic guideline to set up the initial configuration of a Raspberry Pi board together with a PLApp environment. All right, and since on my network at school here for the lab, we're going through a firewall that has a NAT, all that stuff. I'm going to set you guys up where you can have a VPN account into our Global Protect VPN, and then you'll be locally on the network from there, and then you can access your. I'm going to set each student up with one of these Raspberry Pis, so you'll be able to log into it from home or from wherever you want. All right, so we need Prototyping Lab Kit, Prototyping Lab App, Launcher, Application, Prototyping Lab App Image File, Wired Ethernet or Wi-Fi connection to the local area network with DHCP, Raspberry Pi with power adapter, Google Chrome, or other modern web browser. All right, great. All right, so we got everything, I think. I've done this one time, so all right. So task 1 is set up the PLApp, download and install the PLApp launcher, and now I'm going to go through this with you guys. Let me click all this stuff. All right. So let's go to Netacad. Here, I'm going to go ahead and log in. I don't know if you guys had the same problem, but when I hit the login drop down on the home screen to netacad.com, it's always hard to click the options below that for some reason. All right, so I'm going into my course. All right, and so this, and actually, if you see on the lab on 3.2.2.3 on that page, let me go to modules. Here, I'll show you guys. So chapter 3, and you go to 3.2.2.3. All the links that you need to download stuff, you can actually do from right there. All right, but I'm just going to follow exactly the way it says to do it on the lab. All right, navigate to netacad.com in your web browser and enter your IoT fundamentals class, which we're in connecting networks, so we're in there. Move this off the screen. From your student resources page, let me go to that. All right, I'm going to go to home page of the class. Student resources is right here. All right, I'm on Windows 10 machine, so download the PLApp launcher. So before you get the PLApp, you need the PLApp launcher. I'm using Windows, I'm going to click that. It's going to download real quick. All right, click that executable. All right, accept the agreement, read through the software license agreement. All right, I'm not going to create a shortcut, so install that. That'll be super quick. All right, there's the PL launcher. All right, we'll use that in a second. All right, so after successful installation, start the PLApp launcher application. You should see the following screen with the setup a new device tab, which that's right there. All right, download and install the PLApp image. Now, PLApp image is actually this one right here. It says PLApp with CT 2.0 Jupyter notebooks. Now that one is like 1.3 gigabytes. So it'll take a couple minutes to download. I'm on gigabit internet, so it should be pretty fast. I'm gonna move that off the screen though. All right, and then locate your micro SD, and that's a micro symbol right there. So you'll see that from now on. Micro SD card inside the PL kit that is at least 8 gigabytes in size, which mine's 16 gigabytes. It's already inside of the little adapter. All right. So I'm going to take this, and this actually plugs in upside down. So insert your micro SD card into your CD card reader and insert it into your computer. Determine the drive letter of the micro SD card using the File Explorer. Mine comes up as drive E. All right. In the example D, their example right there is D in the app. Let me make sure this download finishes. All right, so my download's almost finished. And you guys probably can't see that, but move this up. Hold on one second. All right, this. All right, see it? It's finished downloading the zip file. All right, now we're going to go back to the launcher. All right. Select the micro SD card removable drive. In my case, hit refresh if nothing shows up, but in my case, it's an E drive. All right. Be careful to select the correct drive. If you select the wrong drive, you can destroy your data on the selected disk drive. Yes, definitely ensure that you have the correct drive letter, because you're going to delete all your data off there if not. All right. So click Find Image. All right. And my image is in Downloads. Notice that it's 1,378,176 kilobytes, so 1.3 gigabytes roughly. All right. Choose that. Notice that it loads it right there. All right, to personalize. All right, we're done with that. So to personalize the PLApp installation on the micro SD card, enter the configuration section of the PLApp launcher application and configure. So device name, and my device name is going to be Mr. McKee. And they want you to do a format similar to that. All right, your first character must be a letter though. So Mr. McKee dash my RPI 1. All right, password. And I'm going to make up a really secure password. Whoops. I'm going to make it password 12345. All right. That's the most unsecure password ever. All right. And that's going to be the password that you use to access your Raspberry Pi. All right. If you have a Wi-Fi SSID and password, you can put it in there. I'm going to hardwire this into Ethernet cable, so I'm not going to do that. So when your settings are correct, click the Write Disk Image button to overwrite all of the data on the selected SD card drive. All right, so right there. So it starts. You can see the status right there. This might take a couple minutes. All right. The process will also write your configuration settings to the SD card in a file called chestnut.txt. Depending on the speed of your micro SD card, this process might take 5 to 10 minutes to complete. Note if the micro SD card has been flashed with the PLApp image, you will only want to change the existing settings. Then click the Update Config Only. All right. And you don't see that now, but that was listed on there. All right, when the micro SD card is complete, use the File Explorer to verify the contents of the micro SD card, and you should see the micro SD card name has been changed to Cisco-PLApp. All right, attention, the current content of the flash will be erased and the Chestnut image will be installed. And there's the target device is my E drive, and it's labeled as none right now. Are you sure you want to continue? Click yes. All right, then it starts. I'm going to pause the video and I'll be back when it's done. All right, so that did take about 10 minutes to install. All right, so add a device. The device with the name I named it is provisioned and ready and is added to list of devices. All right, so that's done. Okay, and that should say Explore. The micro SD card letter, you should see the notebooks folder in the Chestnut.txt setup folder, or setup file. All right, so actually you see Chestnut.txt, open that up. That is where your configurations you put in there for your device name, password, SSD, and Wi-Fi password if you had it. All right, and then also notebooks. All right, so that's in there, and there's a bunch of other files too. All right, so the Chestnut.txt file contains the setup information that was set using the setup of the PLApp launcher. If you need to change any of these settings, you will either use the PLApp launcher with the update config only button to update these settings and preserve all of the other content of the SD card, or edit the file manually. I would just say edit it manually and with a notepad. All right, the notebooks folder contains all of the default lab notebook files that were bundled with the release of the PLApp image that was flashed on the micro SD card using PLApp launcher. If you want the most recent or unmodified version of the lab notebooks, download the notebooks zip archive from the IoT Fundamentals Student Resources page and unpack it to the Networks folder. All right, you can also easily back up either your own notebook files or the course materials by copying this notebook folder to your computer. All right, before removing the micro SD card from your computer, make sure to successfully unmount it. So if I go down here to my task manager, click that. All right, eject USB storage, which is the Cisco PLApp. All right, safe to unmount it. All right, so I'm taking this out. You guys probably can't see that. All right, so I'm gonna go ahead, pull that out. All right. So there's an alternative steps for Linux users. I'm going to skip through that. All right, so step 4 is access PLApp on your Raspberry Pi. Enter the micro SD card into your Raspberry Pi. The micro SD card slot is on the back of the board. Okay, so that's a picture of the back of the board, which is right there. All right, so on this micro SD card, the side with the pins face towards the board itself. All right, slide that all the way in. It's going to be sticking out the side a little bit. All right, and in my case, I'm going to flip that over like that. All right, connect the Raspberry Pi to the LAN. If you're using an Ethernet cable, connect the cable to the Raspberry Pi. If you're using Wi-Fi, make sure the signal from the access point is strong enough. Your computer and your Raspberry Pi must be on the same subnetwork for the PLApp launcher discovery to work. For security reasons, it is recommended that PLApp devices be on a separate network, preferably wired that has no connection to the rest of the school network or has its own internet access to complete the labs that require internet connectivity. All right, so eventually when I have everybody set up their own, everybody has their own Raspberry Pi and Arduino, I'm going to have them on a separate VLAN on my switch. All right, so this is connected to my switch in my office. I'm gonna plug that in to the Ethernet port in the Raspberry Pi, and that's kind of twisted a little bit. All right, so that's good. All right, power on your Raspberry Pi by connecting the micro USB cable with a proper power supply that provides enough current to the Raspberry Pi board. The recommended PSU, or power supply unit, provides 2.5 amps to power the Raspberry Pi 3 Model B. All right, so since I've got a Model 4, I've got a USB-C or USB 3.1, whichever you want to refer it to. I'm going to plug it in right there. All right, once I plug it in, I got a power button, a power light, and then an activity light. And what it's doing as soon as you plug it up, it's starting to boot up that version of Linux that resides on the drive, on the SD card. All right, the red power LED must be always on. If the power LED is blinking or is off, the power source from the PSU is not providing enough power to the board. And I know a lot of people do it, but if you have a charger like for a cell phone, like an Android, that usually doesn't provide enough power for a Raspberry Pi. It'll power it up, but a lot of times it won't be enough power to actually make it function correctly. Because trust me, I've done it myself a bunch. All right. And it is hard to diagnose the problem if you don't know that's the issue. All right. So what I'm going to do though, actually, let me, under this, start the PLApp launcher application. You should see the following screen with the available devices tab. And notice that went from offline to checking. So it's starting to see this. All right. Notice that it has a PIPA IP address right now. As soon as that goes to connect, it should give me a valid DHCP assigned IP address. All right, so we'll just give it a second to do its thing. This is why this is kind of cool. If I had a bunch of different devices on this network, I'd be able to see them all. All right, so while that's oh, there it goes, connect. All right, so the available devices tab lists all of the PLApp devices that have been set up on this computer with the PLApp launcher, or were manually added to the list using the Add Device Name button. PLApp launcher is continuously trying to discover the listed PLApp Raspberry Pi devices that are connected to the network. Once a device is discovered, its current IP address is shown in the list, and a green connect button becomes active. Clicking the green connect button opens a web browser connection for the selected PLApp device. Note, the very first startup of a freshly written micro SD card might take longer to become connected due to the initial setup at the boot up process, expanding the file system of the micro SD card, etc. Click the green connect button of your device in the PLApp launcher to directly connect to the local PLApp web interface running on your Raspberry Pi device. You can use the PLApp based web interface to access existing labs and to write and install new applications, access the Linux shell interface, etc. All right, so if I click on that, a web browser pops up. All right, here's my web browser. So I'm gonna put that right there. Use my password. Oh, and if you type in the password correctly, it works better. All right, I don't want to save that. Read through the software license agreement, click agree. All right, now you're in the web browser for your Raspberry Pi. Notice my Raspberry Pi name. All right, notice how much storage I have and how much storage I'm using, how long it's been on. All right, CPU usage is right here, memory usage is right here. All right, here's the files. stuff that's running. Currently there's nothing running. All right, here's all my course materials, my files, and some other files. All right, so let's see. After successful login, the PLApp directory browser opens the root directory of the notebooks. And if you say, if I go into course materials, click on that, and I want to go back to the root folder, I click the little file or the little folder. Okay. So that looks like what I have right there. This is the PLApp's representation of the notebooks folder that is created on the micro SD card. All right, the basic structure of the folders in the root networks directory is as follows. Course materials, this folder contains Cisco authorized labs in the form of Jupyter notebooks. My files, this file is your space to create your own Jupyter notebooks and other files. So my files is empty. All right. It says note, use this space to note what you've learned in performing this exercise. The notes can include problems encountered, solutions applied, useful commands employed, alternate solutions, methods, processes, procedures, and communication improvements. All right, so basically just do a summary. In our case, if you're in my course, what you've learned doing this lab. Of course, you just watch me do the lab. Now, if you have trouble, if you have any troubles while you're installing this, you can look there, and that's it. So pretty much this is all you need to submit. I'll put a Word document in Moodle. You'll answer your little summary of what you've learned in this exercise and upload that to Moodle, and that's what I'll grade you on. All right, but we're going to be using this in the future a whole bunch more with the other labs. All right, and then eventually we'll connect in our Arduino board. All right, and that's it. Thanks for watching.